So in today's lecture, we are going to cover section 2.4 from your textbook, and we are going to learn how to solve first order exact differential equation, which is the third kind of the first order differential equation. We are going to learn how to find their solutions. But before that, let me remind you what we studied in the previous two lectures, maybe lecture number 2 and lecture number 3. Actually, let me also go through the lecture number 1. We studied the definition of differential equation and this, what is the meaning of solution of the differential equation and the initial value problem and the existence and uniqueness. Then in lecture number 2, we studied the first kind of differential equation, which we are going to deal with them during this semester, which was separable differential equation. And let me write here the definition or the form of the separable differential equation. It is y prime equal hx or gx, let me say, gx times hy. So I have a product between two functions. One of them has only x and the second one has only y. And this equation, to solve it, usually I will write, instead of y prime dy over dx equal gx times hy. And now I'm going to divide by hy and multiply by dx. So I have dy over hy equal gx times dx. And now integrate both sides. So you will get the solution for this differential equation, nothing here, okay? So this is the first kind of the differential equation. We call it separable differential equation. Then we moved to the first order linear differential equation. But now let me start asking some students. I need Abdurrahman.
Yeah.
Abdurrahman? Yes. Do you remember, Abdurrahman, the form of the first order linear equation? And by the way, when I ask any question during the lecture, you can use your notebook to answer me, your cheat sheet. You are free, okay? So do you remember the form of first order linear equation?
Yes, doctor. Isn't it the one that has a node and the
Yes,
a1?
yes. This is the general form of first order linear. You are right. Read it, please. So what should I write now, Abdurrahman?
I just don't remember the exact version of it.
Yes. I'm going to write. Actually, first order linear equation, the general form, it is a1x times y prime plus a0x times y equal f of x or g of x. So notice your y is multiplied by a function of x and your y prime is multiplied by a function of x. No y inside this function. And we wrote the standard form for the first order linear equation to start solving it by dividing the equation by a1x. So the standard form for the first order linear differential equation, it is y prime plus bx y equal f of x. So this is the standard form for first order linear equation. And I remember that we have two steps to find the solution of this equation. Let me ask Ahmed Atif. Do you remember the steps, Ahmed?
Yes, sir.
Yes. The
We
first
write
step, yeah?
mu x
Mu x.
y
Yes.
equals
mu x
integration.
Equal. Okay. It is exponential.
Yes, exponential integration bx dx.
Great. And the second step, please. Do you remember it?
Mu xy
Mu
x.
yes, mu x times y. Yes, you are right. Equal
integration
of
mu x
okay
times f of x
great dx.
dx.
And now by finding this integral, then divide by mu x, you will get mu equal something. This is the solution. So those two steps, thank you very much, Ahmed. Those two steps help me to find the solution of the first order linear equation. This or these all things we studied in the previous lectures. Now, the new thing which we are going to learn today, how to solve exact differential equation. Here are the objectives of our lecture. And before we go through the exact equation, let me ask you one question now. Do you remember the difference? What is the difference between differentiation and differential? What is the difference between differentiation and differential? And by the way, differentiation, it is the same of a derivative. So the differentiation of sine x, it is cosine, and the derivative of sine, it is cosine. But the differential, there is a bit difference between them. Can anyone of you explain the difference between the differentiation and differential? Yes.
It might be in multiple formats يا دكتور يعني اللي هو we might have more than one variable.
No. When we have more than one variable, we have partial derivative. And by the way, I'm going to it's good to say that because I need the partial derivative now.
Okay.
But the differential, no. So look, if I have a function f of x equal maybe sine x, okay? And I need to find its derivative, okay, or the differentiation of this function. So the notation may be f prime, or you can write it df by dx, okay? And the answer now, the derivative of sine, all of you know it is cosine x. This is the derivative. Am I right? Now, if I need to find the differential of this function has a notation df, only df, without the denominator dx. So the difference between the derivative and the differential is in the differentiation, I have df over dx divided by dx. But in the differential, I have only df. And how can I find the differential of sine x? It's very easy. It is the same as the differentiation, so it is cosine x, and I should multiply it by dx. So it's very similar to this, but multiply both sides by dx to get df. So the differential, it is d. The derivative is d over d, okay? So I think now it's easy. Actually, I know all of you maybe now remember this idea. But what about if my function has two variables? At that time, if my function has two variables, so let my function f has two variables, maybe x and y. So at that time, you can't say there is differentiation for this function. You can't say there is derivative for this function. But you can say there is partial derivative, okay? And also you can say there is differential. So the partial derivative may be partial of f by partial of x. So this is the first derivative with respect to x. I call it partial derivative. And look to the notation of the partial derivative, okay? And also there is partial derivative with respect to y. This is, or those are the derivatives with the partial derivative. What about of the differential? So my function has two variables and I can easily find its differential, okay? It can be written like this, df equal, it's a rule, partial f by partial x times dx plus partial f by partial y times dy. I'm not sure if you remember this formula in calculus 3, but it is very easy. So the differential of any function with two variables can be written in this formula. Partial of the function with respect to the first variable times dx, and partial derivative with the second variable y times dy. So did you get the idea now? What is the difference between derivative or differentiation and the differential? And take care that function with two variables, no differentiation for this function, no derivative, but there is partial derivative and also there is differential. Is it clear what is the difference between differentiation and differential? Is it clear?
Yes.
Yes.
Yeah,
Yes.
great. Now, here my function f is z, okay? And I need to find its differential. So I wrote dz or df, it's partial derivative times dx and partial derivative times dy. Sometimes this, but the partial derivative of f can be written in this form. So f and x, this one, that means you have partial derivative with respect to x. Also, this, it is the partial derivative with respect to y, take this notation. Okay, now, look together. If the function f here is x squared, so my f xy now, it is x squared plus maybe sine y also, maybe sine y. And those are constant. Okay, and now I ask you to find its differential. So I need the differential for both sides. So it will tell me the differential of f, it will be, here the rule. So now I'm going to apply this rule. Let me clean those. Okay, so now to find differential of f, so this is f or z, I'm going to apply this rule. This rule need for this side. Now I'm going to find the differential for this side. It is partial derivative with respect to x, which is 2x, times dx, plus the rule said partial derivative with respect to y, derivative of sine y with respect to y, it is cosine y. And I need to multiply it by dy, so it is dy. Equal. Now the differential of any constant is 0 as the derivative. So this is the differential of this equation. Okay. Now, in general case, if I have this f, and I need to find its differential for both sides. So the differential of f equals the differential of c. And the differential of f is given by this formula. So I wrote here the same formula. Partial f partial x times dx, partial f partial y times dy equals 0. Okay? Now, if I call partial f by partial x, I'm going to call partial f by partial x m and partial f by partial y n. Okay? So I have this new equation. Please, now I have a question about this equation. Do you remember this equation? I think in the first lecture we studied this form. Do you remember what we call this form?
The standard form?
No. Yes. Actually, it isn't the standard, but the second student, I can't hear you. Could you please repeat?
Differential form.
Yes, it is differential form. Great. Excellent. So this form, we call it a differential form of the differential equation of first order. Now, look what I need of you to understand. Sometimes I will give you this, and you need to go to this. How to do that? Take the differential for both sides and call the partial derivative with respect to xm and call the partial derivative of f with respect to yn. So it's very easy. Now, in the opposite way, if I give you this and I need you to give me this, I think it's easy for you. If you understand what is the meaning of this m, that is partial derivative with respect to x, and n partial derivative with respect to y, so you can easily go from this to this. And by the way, if I ask you to solve this equation, that means I need you to find the f which satisfy this equation, such that the m, it's partial derivative with respect to x, and n, its partial derivative with respect to y. Okay? So the idea of today's lecture is how to go from the differential equation this into f. Actually, not all the differential equation in this form can be as f equals c. Some of them can and some of them can't. Those equations who can come from this, we call them exact equation. So look now what I wrote here. A first order differential equation of differential form, like this one, we call it exact differential equation. So I will call this exact if the partial derivative with respect to x is m, and the partial derivative of f with respect to y is n. That means this function can be considered as the partial derivative with respect to x of f, and this function can be considered as the partial derivative of the function f with respect to y. Not all the equations we can consider this as partial derivative of f with respect to x. And not all equation we can consider n as the partial derivative of f with respect to y. If I can, so I will call the equation exact. If I can't, so I can't say that this equation is an exact equation. Now let me give you a motivating example. And actually, always in this slide, the motivating example, I'm going to try to guess the solution of the differential equation. And I'm not going to follow the steps which you need to do in your exam. Okay? So this only to motivate the students to understand the idea of today's lecture. Now I'm going to choose, let me choose Ahmed Ahmed al-Nikrashi. Ahmed here. I need to discuss something with you, Ahmed, if you're here. If you are here. So
Yes, hello.
Yes, Ahmed. Now
Yes, hello.
now we are in exam and we need to solve this equation. For me, first of all, I'm trying to check if this equation is separable or no. Can we write all x together in the left-hand side and all y together in the right-hand side? What do you think?
I don't
Actually,
think so.
yeah, we can or no? What do you think?
I don't think we can.
Yes, we can't, because here I have minus and here I have minus. So if you take common factor, you can't separate all x together and
Yes.
all y together. So second question also for you, Ahmed.
No.
This equation linear or non-linear? So it isn't separable. So I moved
It's
to
non-linear.
It isn't non-linear. Why? Why it isn't non-linear?
We have high powers.
Yes, we have y power 2 and y
Squares.
power 4, and we have also x squared. So this equation isn't linear. You are right.
It's
So
non-linear in x or y.
yes, so it isn't linear in x and y. So in your exam, you checked separable? No. Checked linear? No. Now let us move to try to solve it as an exact equation. And I noticed now to solve any equation as an exact equation, I must write it like mxy in differential 4 times dx plus nxy times dy equals 0. So first of all, before you try to check if it is exact or no, you need to write your equation this similar to this formula. So what should I do to write my equation in this formula, Ahmed?
First, I'll cross multiply to have
Great.
new denominators.
Yes, great. So it will be dx maybe, or let me open a bracket. It will be 3x squared minus y squared. Am I right? 3x squared minus y squared dx equal 2xy 2xy minus 5y to the power 4 dy. Am I right? Now I'm going to move this term here. So it will be 3x squared minus y squared dx minus... so if you moved this here, so you will write minus, and I'm going to inside the minus, so it will be plus 5y to the power 4 minus 2xy. Can I write like this now? Clear,
Yes.
Ahmed? Yeah. So thank you now, Ahmed. I'm going to
Yes, it's clear.
ask Gina a question.
Thank you, doctor.
Yes. Now, my idea that this one, it is m. This one, it is m. And this one, it is n. So this m, it's partial derivative of f with respect to x. And this n, it is partial derivative of f with respect to y. Can any one of you guess the function f of x and y such that if you differentiate it partially with respect to x, you will get this. And if you differentiate your f partially with respect to y, you will get n. Can anyone of you guess the function f now? Only by guessing. Yes, we need to speak.
Do I integrate them or?
Yes, maybe. Actually, now, by guessing, I need you to tell me, Professor, I can choose my f to be like this and this and this. And I will check if you are right or wrong. Yeah.
Maybe it's
X minus y cube, for example.
So let me write x minus y cubed. So I'm going to write what you said, and I will check. So x minus y cubed, only this one you need me to write?
And y minus 2x.
So after y cubed, so, Omar is speaking, yes?
Yeah.
So do you want me to write x minus y cubed, then? Just 1 minute, Basil. Continue, Omar.
Then the other equation plus.
No, Omar, I'm not going to integrate this equation. No, I need you to tell me, Professor, I can choose my f. I can choose my f such that if I differentiate it with respect to x, I will get m. And if I differentiate it with respect to y, I will get an n, this n. I'm not going to integrate this equation, no. Because
Okay.
you can't integrate it because you have here x and y multiplied by x.
Yes, yes.
Okay, so now Basil and Marwan and David need to answer. But Basil, who was the first one, raised his hand. So Basil, yes, what do you want to say, Basil?
So I'll be guessing like x cubed
So let me write here x cubed, okay,
minus xy squared
minus xy squared
plus y power 5.
plus y power 5. Great, and I'm going to check, but let me ask David and Marwan. Do you want to say another thing, David and Marwan, before we check that Basil give me the correct answer? What do you think, David and
I
Marwan?
was going to say the same thing.
David and Marwan?
Yes, I think it's
The
right.
same. So let us check. Let us check this function. Now I need to check if it's partial derivative with respect to x. So partial f by partial x. It is the derivative of x cubed, it is a 3x squared. The derivative of negative xy squared with respect to x, now it is negative y squared. The derivative of y to the power 5 with respect to x, it's 0, so plus 0. Now notice this one is similar to this. Nice. Let me check the second one. Partial f by partial y. So I need to differentiate this with respect to y. Differentiation of x cubed is 0 because I'm going to differentiate with respect to y. Differentiation of negative xy squared with respect to y, it is negative 2xy. Great. Differentiation of y to the power 5, it is 5 y to the power 4. And yes, nice. This is similar to this. So because you can guess this f, you will tell me the solution of the given differential equation is this f equal to c. This is my solution. This by guessing. But after two slides, I'm going to explain the steps which you have to follow to solve the exact equation. Okay? By the way, the steps are 5. Okay, and maybe to write all those steps you need 10 minutes maybe, but by guessing, like some students now, maybe in 1 minute they can find this function. So if you in your exam can guess the solution immediately in 1 minute, you will take full mark, no problem at all. But you have to tell me it's an exact equation and its solution f equals something equals c. You will receive full mark. Okay, but if you can't, actually in the exam I'm not going to give you a simple equation, so I need you to follow the steps. So at that time you have to study the steps in details. Okay, let me now, what is my name? Yes, just 1 minute. So here I wrote that the equation in this form as you told me before, and here I checked if this is the partial derivative with respect to x, and this is the partial derivative of y, and I wrote here the solution as you say. Here are the details also, no need to rewrite to explain them again. Now I have a question. If I have an equation like this, which is differential form, now this equation is exact or no? How to check if the differential equation in differential form is exact or no? I should follow the following theorem here. So you have here in this theorem, this form, the differential form. Notice this form, the differential form. Function times dx and function times dy. Let us agree always the coefficient of dx, it is m, and the coefficient of dy, it's n. By the way, you can choose another notations, but to make the course easier, I think let us agree always that the coefficient of dx, it's m, and the coefficient of dy, it's n. Now, you have this differential equation in this form, and you need to check if it is exact or not. The condition of exactness is the following. You have to take the coefficients of dx, which is m, and differentiate it with respect to y. Okay, and also take the coefficients of dy and differentiate it with respect to x. If those two amounts are equal, then the equation is exact. Repeat, take the coefficients of dx and differentiate it with respect to y, and take the coefficients of dy and differentiate it with respect to x. If those two amounts are equal, then the equation is exact. How to solve it? I'm going to explain in details in the coming slides. Just 1 minute. Now I have
Doctor,
example. Yes, ask.
what do you mean by exact?
Yeah, good question. Exact equation, that mean you can find if this f which we found here, such that if I take the differential for both sides, so you'll take differential of x cubed minus x y squared plus y to the power 5 equal differential of c. Now I'm going to write this, the differential of c is 0, and the differential of this term is given by this rule, and by finding partial derivative of f with respect to x and y, I will get this. So now this equation is exact because it comes from this f by taking the differential for both sides. So exact differential equation, that means this equation can be concluded from a function by finding its differential. Doctor, sometime, so that means you have some equations and those equations can't come from specific function by taking its differential? Yes, actually sometimes. Look to this equation. Now x dy, x dx, sorry, plus also x dy. Now x dy. Can you find a function such that this is its partial derivative with respect to x, and this is its partial derivative with respect to y? Can we guess a function like this? If you differentiate it with respect to x, you will get x. And if you differentiate it with respect to y, also you will get x. Can we guess a function like this?
No.
No. So this equation isn't exact. But if I can guess like this one, so I will call the equation exact. Now, guessing sometimes is very difficult. So I need some conditions and specific steps to find the solution, or first to check if it is exact, then to solve it. Is it clear what I mean by exact equation now? Exact differential equation?
Doctor, I don't understand how to make sure it's exact or no.
Yes, now I'm going to explain again. Depending on the theorem, yes? But now my question, is it clear what I mean by the exact word? And when I say exact equation, did you get the idea? Not the condition.
That they don't have the same coefficients, so they are exact, yeah?
No need. Let me check again. Let me give you another example. So here it is 1 plus x times y, times dx, sorry. And here plus, sorry, it is x plus y. X plus y dy. Okay? Let me check if this equation comes from a specific f, such that this is partial derivative with respect to x, and this is partial derivative with respect to y. Can we guess? Now by guessing, not the condition. Okay? If you can guess, if there is really f, a specific function, such that if you differentiate it with respect to x, you will get this term, 1 plus x. And if you differentiate it with respect to y, you will get this. Actually, no at all, no function f, such that its derivative with respect to x, 1 plus x, and its partial derivative with respect to y is x plus y. So this equation isn't exact. But for this one, one of my students can guess easily that this equation comes from finding the partial derivative of a specific fxy is given here. So when you, just to say, when you can find this f, you will call the equation exact, not the condition now. Okay?
Okay.
Yeah. Yes, we need to say something.
No, it's clear now. Yeah.
It's clear? Yes. Now,
Doctor.
this is the definition of the exact equation, not the condition and not the steps to solve the exact equation. Only the name exact equation. That means this equation comes from the differential of a specific f. Okay? Clear?
Yes,
I have a
doctor.
question,
Yeah.
doctor.
Yes, go ahead, ask.
Who I kept saying that it's exact if I could guess it. But I don't understand. Do we classify it as exact if we can guess it, or if it's solvable, or we were able to find it somehow?
If you can guess f, okay, if you can guess like this f, so it is exact, and this is the solution. Okay. This in your exam also, you will write it is exact, and this is the solution, and you will receive full mark. But sometimes I will give you complicated equation. you can't guess this. So what should I do?
It's not
So-
exact then?
No, not maybe you can't guess, but for me as a professor, I can. And also maybe one of your colleagues can guess. If so, instead of guessing, if I have an equation and I can't guess immediately the f, what should I do? I'm going to follow the theorem, which will give me a specific condition. Then I have some steps, I should follow them to solve the equation. Okay, so let me go to the following equation and you will understand more. Look now, here, look to this equation. Here, this equation. Can you see the last equation here? Now, let us consider this equation in our exam. This equation isn't linear because I have tan inverse of y, and it isn't linear on x because I have sine x squared, and I can separate it. So I need to check, can I solve it as an exact? That means, can you guess a specific f such that its differential will be in this equation, similar to this equation? For me, actually, as a professor, I can't. It's very difficult because I have tan inverse, I have exponential. Maybe dealing with exponential is maybe easy, but tan inverse y, it's very complicated function. So for me, I can't guess. So doctor, if I can't guess, should I say it isn't exact? No, you have to go through the condition, which depending on it, you can say it is exact or no. Where is the condition? Look, let me go back and explain the condition here. This is your equation now. Just a minute, I'm sorry. This is your equation. So you have to write any equation in this form. Function times dx and function times dy. Now, take the function which you multiplied by dx and differentiate it with respect to y. So the coefficient of dx differentiate with respect to y. And the function, which is coefficients of dy, differentiate it with respect to x. If those two amounts are equal, then you will say it is exact equation. You didn't solve it till now, but you said it is exact, and there is one can guess the f. I can't. It is exact, but I can't guess the f. Okay, so let us consider this equation in your exam, and you checked those two conditions and you found them are equal, and you wrote it is exact. You will receive 2 marks out of 10. If you can guess f, you will receive also 8, so those are 10. If you can't guess f, but you will follow a specific steps, which I'm going to explain now. So here I have 5 steps. I should follow them to solve exact equation. Okay? Before I go through those steps, let me solve the question here. So in this example, he asked me, is the differential equation below exact? So he need me to check if it is exact. And if yes, solve it. He need me to solve it. Let us first check if it is exact or no. Now, before I go to black slide, is it clear what I mean exact solution and how to check if it is exact or no? Is it clear?
Yes.
Yes. Yeah. So let us go to a black slide here, and I'm going to use the yellow. Before the yellow, just a minute. Let me determine your f and your m and your n. The coefficient of dx. This is my m, and the coefficient of dy, this is my n. Okay, and I'm sorry, I need to choose one now to help, but let me use the yellow. Let me ask yeah, I need Muhammad Zamil here. Muhammad Zamil. Nadir.
Yes, sir.
Muhammad here. Yeah, is Muhammad here? So let us together check if this equation is exact. To check if the equation is exact, I have two things. I should find them. The partial derivative of m with respect to y and the partial derivative of n with respect to x. Okay? Let us together now find the partial derivative of m with respect to y. And please, when I ask any one of you during the lecture, isn't necessary to give me the correct answer. Only I need to be sure that the students in my lecture and can participate, okay? Now, but also this question is very easy, I think, Muhammad. I need you to find the partial derivative of m. This is your m with respect to y. So now my x here is constant because you need to find partial derivative. Yes, start please. You need to find, first of all, the partial derivative of this product with respect to y. Can you? What do you think, Muhammad? Do you remember the partial derivative? Actually, I can't hear you, Muhammad. Yes.
I'm not really sure يا دكتور بصراحة.
Yeah, no problem at all. Let us together do that. First of all, here you have a product. Yes. Do you remember the rule of product differentiation? It is what? I'm not sure if you are speaking, Muhammad, and I can't hear you. Are you speaking now? Yes.
Doctor, can I help?
Yeah, Muhammad, yes. But I think there is a problem with the voice of Muhammad Zamil. I'm not sure. Give me 1 minute. Yes, Marwan, do you want to ask or do you have to? Do you want to answer?
Possible.
Do you have a question?
No, I want to answer if possible.
No, just give me 1 minute because I need to be sure all the students can do this. Now I have a product between two functions. The rule of a product between two functions, if you need to differentiate it, is as the following. The derivative of the first function, which is y, and the derivative of y with respect to y, it's 1, times the second function, which is e to the xy. Please, who forget, you have to do some revision for differentiations. Plus derivative of the second function. Now my second function, it is exponential. And to find the derivative of the exponential, I need to differentiate its power. And my power now, it is x times y. The differentiation of x times y with respect to y, it is x. So I'm going to write x here. Times the y, which is the first function, times e to the xy. Okay, minus. Now the differentiation of x times sine, it is 0. Why? Because I'm trying to find the differentiation with respect to y. So this is 0. Okay. So thank you, Muhammad Zamil. And now I need Muhammad, yes, Muhammad al-Jibaili.
Gibeli? Yes.
Yes, Muhammad. Then I will go to Marwan. Your time to find the partial derivative of n with respect to x. This is your n, and I need the derivative with respect to x. Also, you have a product now.
Yes.
Yes. Go ahead.
So the first one will be e to the power of xy.
You are right. So it is 1 times e to the xy, which is the derivative of the first times the second, plus continue.
Plus yx e to the power of xy.
Yx e to the xy, great. Y, it is the derivative of up times x, the first function, times the exponential, plus continue, please.
0.
0, great. So here, the derivative of tan inverse of y with respect to x is 0. Sometimes the students forget that here the y is constant. And they will ask, Professor, how to find the derivative of tan inverse? No need to find it, it's 0 now. Okay. Now check, please. Those two amounts are equal or no? What do you think? This and this? I think are equal those, because x e to the xy plus yx xy is the same. So those are the same. So my equation, it is exact equation. Okay.
Doctor, for the zeros, why do I have a negative 0 and a positive 0?
Why I wrote here negative 0 and why I wrote here plus 0? This is your question?
Yes, yes.
Yeah, the derivative of x sine x squared, it is 0. So I wrote here
0.
negative 0. And
Okay,
here,
okay.
the tan,
Okay.
so no need to write them, actually, no need at all. But for me, I prefer to do, especially in the beginning of my course, everything in details for those who forget how to differentiate. Okay? Is it clear now? Can I move to the question how to solve?
Yes, yeah, doctor, yes.
Doctor, what if they are not the same?
So the equation isn't exact, Ataman. The equation isn't exact, and I can't solve it as an exact equation. Maybe we can do that in the coming lectures. So the equation maybe will in a specific kind of the differential equation, which we are going to study in the coming lectures.
Okay. Okay.
Great. Other questions? So let me now go to the question how to solve this equation. So if it is exact, I'm going to follow the following steps. Here are the steps. Actually, this slide is very important, and I ask each one of you to take a photo or print screen for this slide. I'm going to ask randomly any one of you to tell me maybe first step or second step or third step. So take a photo of this slide, please. All of you, please. And let us go and try to solve this equation here. I'm going to solve this equation, which we studied now. It is exact. Okay? So here the solution. First step, let me go back to my slide. So first step here, look. Or let me read the steps before I start solving the problem. Let me read the steps. So first step is to check the condition here. Second step is to write, don't forget, let me use here some the red pen. Don't forget that the solution of this equation, which is exact, it is f xy equals c. So your aim is to find this f. Okay? Now, to find this f, in second step is to write the partial derivative of the f, which I don't know and I need to find, to be the m. So second step, choose the partial derivative of your f, which you need to find, to be the m here. And don't forget that because this equation comes from partial derivative of f with respect to x times dx plus partial derivative of f with respect to y dy equals 0. So here I choose this the partial f by partial x to be m, and I choose it to be second step. Third step is to integrate both sides of this equation. Don't forget, if you integrate here, so it will be integral of partial f by partial x dx equal integral of mxy dx. Now I have a question. What about of this integral? Integral of a derivative. It is what? The integral of a derivative. It is what?
The function itself.
The function itself. Great. Mumtaz. Great. This is f. And the integral of f of m, that depends on our problem. So I will give you a specific m and you will integrate it depending on the problem. But don't forget, when you need to integrate, you have to add a constant plus c. And because your integration with respect to x, that means this y is constant. Okay? This y is constant. So the constant which you need to add must be a function of y, because your y is constant. So the idea here I wrote here gy, which is my constant. I choose my constant to be a function with respect to y because my unknown function has two variables, x and y. So I integrated with respect to x, and I consider my y as a constant. So the constant integral must be a function with respect to y. So this is the third step. The fourth step is to find the derivative of this function, which you found here, this function. Find its derivative with respect to y and let it to be n. Because here you have, notice, here you have the partial f by partial y, it is n. Okay. Then from this equation, step 4, I'm going to find gy by integral both sides. By finding integral of both sides, then I will get the f equals c in step number 5. Let me do everything in details in the following example, and you will find it's very easy. But you need to take a photo of this slide, okay? So here I remember first step is to check if, first of all, I need to determine my m and my n. Let me use the blue. So my m is this function. This is my m. And my n is this function. And I checked that partial derivative of, the partial derivative of m with respect to y, it is partial derivative of n which with respect to x, so the equation, it is exact. This is the first step we did in the previous slide. Second step is to choose your f such that partial derivative of f with respect to x to be your mxy. Okay, that will give me partial derivative of f with respect to x. It is my m. Where is my m? It is y e to the xy minus x sine x squared. Any question here about this step? Now I'm going to integrate both sides with respect to x. So let me use another color here, and I'm going to write the following. So take the integral here with respect to x, and the integral here also with respect to x. And actually now I need some help, and I'm going to choose maybe. Let me choose now Ziad. Ziad, can you help Ziad? Ziad Salim. What do you think, Ziad?
Yes, doctor.
Yeah, I think it's very easy for you. Now, the integral of derivative of f, it will be what? If you have integral and differentiation, so it's a rule.
هيكنسل بعض.
You're great, so it will be f of x and y equal. Now you need to integrate this function, note the first one, this, with respect to x. So your y is constant. Don't care about y at all. How to integrate exponential function?
Won't we هننزل the x and y تحت? We'll keep it.
Yeah, we will divide by what? Repeat.
We'll get the x and y down.
Both of them. What do you think? So if it is, look, Ziad, if it is e to the 2x instead of y, because y is a constant now.
Yes.
So it will integral. Yes, only 2. So now the y will be down. So it is y
squared.
No, it will be no. Actually, if you need to integrate, you have to divide by 2 and divide by y. So it will be e to the xy divided by y. Okay.
Okay.
When you need
e for x by y.
Yes, you are right. When you need to differentiate, you will multiply. When you need to integrate, you will
We'll
divide.
Okay.
Okay. Now, what about of this integral? Is the second one. Yeah, how to integral to find this integral, which is x sine x squared. Maybe is more complicated than the exponential function. So I need to find this integral.
We can use substitution, doctor.
Yes, who is speaking?
Omar.
Yes, Omar, great. So thank you, Ziad. Thank you very much, Ziad. And Omar, continue, please. Which substitution do you want me to use?
We're gonna use u in place of x squared.
So u equal x squared. That will give me du equal 2x dx, and that mean I have dx equal du over 2x. So I'm going to write here minus integral of x sine, instead of x squared you asked me to write u, times instead of dx I'm going to write du over 2x, and I'm going to cancel this x with this x. Okay, let me go back to the yellow, and here actually, yes, I didn't integrate here. So where is the yellow? And by the way, some students in the previous section, some of them immediately asked me, Professor, multiply by 2 and divide by 2 here near x, and you will get the integral. It is half cosine x squared. Let us continue and we will check. So from this I can write the f is I cancel y with y, so it is e to the xy minus. Now the 2 is a constant, take it out. What about of the integral of sine u? The integral of sine u, it is
negative
cosine u. Okay, you need to add a constant plus. Notice now the constant. You need to write c. Okay, but now you integrate with respect to x. Here, your integral with respect to x, and your function f. Notice your function f has two variables, x and y, because you integrate with respect to only x. So your constant c must be a function with the second variable, which is y. So it is cy, function of y, or you can write it gy, no problem for me, cy or gy. Okay, from this equation, I can say my fxy equal e to the xy plus half cosine, instead of you go back to your x, so it is x squared plus do you want me to write cy or gy? You are free. This is the second step. I found the f. Third step. Now to do the first step, I'm going to choose Rana Al-Gamal. Rana here. Rana? Yes, can you hear me, Rana?
Yes.
Yeah. Do you remember third step, or do you want me to go back to the slide?
No, I remember. We need to find f.
It will be what?
هو third step المفروض we can find f by integrating الأمر.
Yes, I'm sorry. Yeah. So here the third step. Let me write here the third step. I'm sorry. And here the fourth step now. Am I right here?
Okay.
Yes.
We should differentiate with respect, differentiate f with respect to y.
Yes, differentiate of f with respect to y and let it equal to your n. Am I right? Yeah, that will help. That will give me. Now your f is written here. And by the way, just 1 minute. You found your f, the solution now. This is my solution. But unfortunately, my solution has cy and I don't know cy. I'm going to find cy as the following. I will choose the partial derivative of y to be n, and now I'm going to substitute. Yes, Arana, help me to find the partial derivative with respect to y of this function.
Okay.
Yes.
with
The
respect to
partial.
y, it's gonna be x.
X. Continue.
Exponential function
Of
with respect to y. لا مش y. x y.
xy. Usually, when you try to differentiate any exponential function, you will differentiate the power times the same function, the same exponential, the same power. Okay? Plus. Continue, please. The differential of half cosine x squared with respect to y. It is the differentiation of cosine x squared with respect to y. Don't forget, when you need to differentiate.
0?
Yes, you are right. When you need to differentiate with respect to y, that means x is constant. Continue, please. What is the differential? The differentiation of cy with respect to y?
C.
C? I'm not sure. Look, Rana, cy, it isn't a product. It is a function. It is a function with respect to y. Do you want me to write it g instead of c? Let me write it g instead of c. G of y, to know it is function. What is the derivative of the function gy with respect to y?
G dash times y.
G dash y, you are right, G dash y. And all those must be your n. Where is the n now? What is the n? This is the n here. Here the n from your equation. So it is x e to the xy plus tan inverse of y. Am I right here? Is it clear, Rana?
Yes, it's clear.
Yeah. Could you please only simplify this equation, and if you can cancel any terms, can we cancel anything here?
Yes, we cancel x exponential times.
Yes.
Yeah.
Yes, you are right. So g prime y, it is tan inverse of y. Notice always in step number 4, you should get an equation contain only y. If you, in your exam in step number 4, you have x and y, that means you did something wrong. Okay. Last question for you, Rana. I need gy. I don't need g prime y. What should I do? I need gy, no g prime y. So what should I do? Only take the integral for both sides.
Integrals, huh?
Yes, take the integral. So gy equal integral of tan inverse of y dy. So here by taking the integral. Yes, thank you very much, Sharon. Now I need one to tell me how to find the integral, of tan inverse. How to find the integral of tan inverse? Can anyone of you remember how to find the integral of tan inverse?
It's cosine over sine.
No, this is This is the inverse function, not the flip tan and cotan. This is tan inverse. It is arc tan to the -1. It is arc tan, not 1 over tan. Okay, you remember the inverse functions? So how to integrate tan inverse y? By the way, it's a very simple function in calculus 2. And you can find its integral in Google if you need. And you can write it in your cheat sheet. But for me, I advise the students to do it using a specific technique. Anyone of you remember the technique? Rahma?
By substitution.
Yeah, which substitution?
I'm gonna consider tan minus 1y is u, and 1 over 1 plus x squared is du.
But just a minute. Yes. And then? By the way, Rahma, you approximately right, but actually this technique, we call it integration by parts. Yes, it is substitution, but you need to choose your tan inverse y to be u and dy to be dv, and apply the rule of integration by parts. Okay, so now all of you, you should do this integral, the last one, by parts, and send me your solution on WhatsApp as a private message. Okay, so the homework class today is only to do this integral by parts. I need to let you do some revision about the integration by parts. Okay, and you can find its integral in calculus 2. Now I wrote the answer here. So this is equal to y tan inverse of y minus half ln 1 plus y squared. This is the integration by part for tan inverse y plus c. Now I found gy. Last step now, I'm going to write last step here, 5. My fxy, which I found here. Only I need to substitute the gy equal e to the xy plus half cosine x squared plus the gy, which I found y tan inverse y minus half ln 1 plus y squared plus c. All of them must be equal to c1. I will move this c here and subtract between all of them, so it is equal, maybe equal c or minus c1, don't care, only I need c plus c equal c, and that's enough. Don't care about the name of the constant. This is my solution of the differential equation. So do you have any question about the steps? I'm going to do another problem now to be sure.
Can we repeat the last step, Dr. Marij?
Number 5.
Yeah.
Okay. Number 5, only go back to your f, which you found in number 3. Okay. And substitute the g, which you found here. So plug in 4 in 3. Plug in number 4 in 3. Okay. So any question, or can I go to the second problem? Now, those I did here, I need you to write your name in chat, please. Write your names in chat, in our chat. All of you, please, write your names. All the students should write their names as an attendance policy now. Here I have 4 problems. 3 of them are included in our worksheet. So I'm going to solve number 16, which isn't in the worksheet. All of you write your names, please. Now, what I'm going to do, first of all, this equation isn't separable because here I have minus. Can we consider this equation linear or non-linear? What do you think?
No, it's linear, Doctor.
Linear. You said it is linear. But for me, it isn't linear. Why? This equation, it isn't linear. Notice why. Because here you have the coefficients of y prime. It's a function with respect to y. And as I wrote in the beginning, the form of the linear, it is a1x times y prime plus a0x times y equal gx. Now, instead of, or your a1x, which is a function with respect to x, contain unfortunately y. So your y prime multiplied by y. So this equation isn't linear. And it isn't separable. So let us check if it is exact or not. To check if it is exact, I should write this equation. So here the solution in the form mxy times dx plus nxy times dy equals 0. So what should I do to write my equation in this form? I'm going to write my y prime as dy over dx. So it will be 5y minus 2x times dy over dx minus 2y equals 0. Now let us multiply by dx. So I will get 5y minus 2x dy minus 2y dx equals 0. Where is my m and where is my n? I need some help. Where is your m and n?
My
m is
n
5y minus 2x.
So you said my m, it is...
no, it's the n 5 minus 5y minus 2x.
You are right. You are right. This is
yes.
n. This is n. And this is m. So some students usually prefer to start by dx. So they will write minus 2y dx plus 5y minus 2x dy equals 0. This is your m. Please don't leave the meeting. It is very important lecture. And this is my n. Now, steps for exact equation. First step is to find partial m by partial y and partial n by partial x. Now, the derivative of my m with respect to y, it is only -2. And the derivative of my n with respect to x, here y nothing, and with respect to x, it is -2. So those are equal, so my equation, it is exact. So I can follow the steps. Second step is to choose your f such that partial derivative of your f with respect to x will be your m. That will give you, if you take the integral of partial derivative of f with respect to x to be, here times dx, to be integral of my m, which is -2y times dx. Now, this can be written as f of xy equal -2xy, because I integrate with respect to x. So my y is constant. So I need to multiply by x plus a function with respect to y. This is my third step. Now, do you remember fourth step? Can anyone help to write fourth step?
We need to find gy.
Yes, how to find the gy? By finding the differentiation of the f, which I found in step 3 with respect to y, and let it to be n. That will give me. Now, partial derivative of this with respect to y, it will be -2x plus g prime y equal my n. Where is my n? This is my n. This is my n, which is 5y minus 2x. Now I can cancel 2x with -2x. That means my g prime y, it is 5y. 5y. Can anyone of you give me the value of gy now? Gy is what? Gy
5 over 2y
5
squared.
over 2y squared.
5 over 2y squared. Great. This is the fourth step. Now, fifth step, you can add here constant. You can add, or you can leave it as 5 squared, and the fifth step, it will be my f, which I found in step number 3, equal -2xy, and the gy, I found it in step number 4, which is plus 5 over 2y squared. All of them must be that constant c, and this constant with no x and no y at all. This is my solution. What do you think about the steps? Do you have any question? So
No, thank you.
Yeah, actually the time is up. Now let me tell you that 14, 15, 17 are included in your cheat sheet. And if you need, we can meet at 1 o'clock. So if you have any question, or we can do it together if you need. Okay?
Doctor, I have a question.
Yes, ask.
Well, do I have to start with M, or can I just integrate whichever is easier?
Yes, you are right. So you can start instead of partial m by partial, you can start instead of partial f by partial x equal m, you can start by step number 4. So partial f by partial y equal n, and then integrate. You are right, you can do that. But take care that here x with m and here y with n.
Oh,
Okay?
yes, I understand.
Yeah. Who is speaking
Okay,
now?
thank you. Muhammad Al-Gabeli.
Yes, great, Muhammad. Good question.
Thank you.
Welcome. Other students? So if you have any comment about the worksheet, okay? I hope the course is easy, but you need to practice and solve everything in details. And now, if no questions, I can leave the meeting, and I hope the best.
I have a question.
Yes,
why
sir.
it's not linear?
Why this? So let me go back and explain why it isn't linear. So for those students who need to leave, you can. Okay. I'm going to explain why it is non-linear. Let me write here in red. Okay. The equation, it is 5y minus 2xy prime minus 2y equals 0. I know the general form for the first order linear equation is the following: a1x, that means function of x, times y prime plus a0x, it's a function of x times y equal fx. Now fx, it's 0. a1x, it's -2. Am I right? Because y and y. This is y prime and this is y prime. Let me check the coefficient, this and this. Unfortunately, the coefficients of y prime has y, but the rule said it must be a function of x. So because here you have y, so this equation isn't linear. The rule said only function of x.
أنا لو جربت أضرب مثلا أو أوزع distribute على
Yes,
y.
I will do that. I will do. So here you asked me to distribute. I will do that. So it will be 5y y prime minus 2x y prime minus 2y equals 0. Now for me, immediately this equation isn't linear. Why? Because I have a product between two y's. Two y's, so it isn't linear. Because I have a
y and y prime. ده معناه برضه
yeah. So those are y. Both of them are y, but one of them with dash. So both of them will be my function. One of them my function, and the second it's a derivative. So it isn't linear. It is non-linear. By the way, let me explain in more details. If you have x plus y equals 0, what do you think about this equation? Linear or non-linear?
Linear.
What do you think? Now I'm asking you about x and y, both of them. What do you think about x squared plus y equals 0?
Non-linear.
What do you think about x plus x times y equals 0? What do you think about this equation?
Linear.
No, non-linear. Why? Because it has product between two unknowns. I'm speaking about algebraic equation, not about differential equation.
Doesn't have to put a power. Just multiplying.
Yeah, now look, great. Here the power is 2. And by the way, here for x and y, the x with power 1 and the y with power 1. So both of them together will be of power 2. So this equation, it isn't linear. So always if you have a product between the unknowns, so the equation, it isn't linear. So here my unknowns, x and y. Here in this equation, in the differential equation, I have only one unknown, which is y. But unfortunately, I have a product between my unknown y and its derivative. And I don't know both of them. So this equation is non-linear.
هو برضه 2x y prime برضه non-linear.
No, this one is linear. Why? Because my unknown is y prime or y, but the x now it is independent variable. Yes, it is independent variable now.
Okay, شكرا دكتور.
Okay. Other questions?
Doctor, yes. Please can you give me a quick recap كده أو summary the way that I approach the question. أنا مش فاهم، أنا بتلخبط بس اللي هو when should I use M and N, and when should I use the thing we discussed last lecture?
Yes.
Using
Yes.
inseparable.
Yes, I can.
And
do that. So about this equation, if you need, let us speak about this equation.
Okay.
The same one. Also, I can go back to one of those if you need. Look, what do you think, Ataman, if you started, if you joined with us at 1 o'clock, and I'm going to explain what you asked me for all the students. What do you think that? Is it good? Do you have time?
Yes, I have time.
So at 1 o'clock, we are going to discuss 14, 15, 17, and we will do the revision for all the previous ideas.
No, but I mean, Doctor, يعني, overall about what we took till that lecture, about the previous lectures, يعني, like a small summary.
Yeah.
So at 1 o'clock also?
No, I'm going to do that now. Okay. We studied first kind of differential equation, we call it separable. Separable, okay? And separable differential equation, that mean you have y prime equal function of x times function of y. If you have the right-hand side as a product between two functions, so it is separable. Then, in third lecture, we studied first order linear. First order linear, that means my differential equation, it is y prime plus bx y equal fx. So those two kinds we studied. In today's lecture, we studied the exact equation. Exact equation. That means you have m times dy plus n times d, m times dx, I'm so sorry. M times dx plus n times dy equals 0, such that here you need the partial derivative of m with respect to y to be the partial derivative of n with respect to x. So I studied only those three, but actually in the coming lecture, we have more kinds.
Okay, okay, yes. And in number 2, we will use number 2 first order linear when the equation is linear, right?
In this form, yes, you are right. And here, yes. I have 2 steps to do that. I'm going to find the mu, which has specific rule, and I'm going to write mu times y equal integral of mu times f.
Yes, I know this. I'm just a bit confused about the first and the second. Yani when to use the second and when to use the separable. When it's first order linear and when...
Actually here, this hy, maybe it is sine y. So if hy it is sine y, you can't use first order linear because the sine, it isn't linear function. Okay? Maybe here in hy, you have y squared. So if it is y squared, it isn't linear. So actually, there is a specific form for the linear. No y squared, no sine y, okay? And no 1 over y.
So separable doesn't require the equation to be linear, but the first order linear requires it, right?
Yes, you are right, yes.
Okay, thank you, Doctor.
Yes, welcome, Atman. Other questions? Anyone have a question?
No, thank you, Doctor.
Yes, welcome all of you. I'm going to leave the meeting, maybe only 5 minutes, and I'm going back, okay? So bye-bye all of you.
Okay, bye.
Bye-bye.